Assalamualaikum warahmatullahi wabarakatuh. Welcome to our presentation, which is Mechanical Transportation for DBT 253. This case study was conducted at Wisma Tani located in Presin 4, Putrajaya, Malaysia.
First, we need to know what is a building service. Building service is a supply system in building for comfortable, safety and functional to people. Building service include the electrical system, telecommunication system, mechanical system, fire safety system and smart building. Chapter 1. Introduction to lift and elevator. Objective of this case study is to assess the maintenance practice of the lift system. And next, we want to evaluate the efficiency, capacity and reliability of the lift system. And the last, we want to explore about what things are there at motorroom. That's all from me. We move to chapter 2.
Introduction of case study. The case study is located in Presin 4, Putrajaya. It serves as main office for Ministry of Agriculture and Food Security. It has 18th floor and corporate building type. We move for second part is project background. The name of project is construction and completion of main building and external work for government building. The architecture is Jeffrey American Architect. The project is started in 2001 until it complete around 2004 and 2005. The mechanical engineering is Muhammad Zuwali Kifli bin Muhammad. We move for the last part is location plan. This building at the corner of Jalan P4B and Lebuh Setia. It is the main government area and the design of the building is curved building layout. It has several blocks including block 4G2. That's all for me. Thank you.
Chapter 3. Literature Review. In literature review, we have a type of system. The type of system at Wisma Presin 4 in Putrajaya the elevator type is traction elevator system. The traction elevator system has a lot of advantage. At Wisma Presin 4 Putrajaya, the type of elevator they're using a traction elevator system which using ropes and counterweights pulled by motor in motor room. This type of elevator is suitable because the building is an 18th floor of corporate building. The building type is corporate building because it's a government building. Next up is a component of the system. So the first component of the system is traction sheath or traction machine. The traction machine are a vital component in the traction elevator system that function as the main driving unit. Act like a motor that drive the car lift that transporting people inside it. And in traction elevator system, it is consists of two types of traction machine. It's either geared or gearless. It depends on what the requirement that they need. But in Wisma Presin 4, the building, the elevator in Putrajaya, they use gearless electric motor that spins the traction that control the car lift. The advantages of using the gearless motor it's more reliable and of course it's much smoother. Next up is the braking system. The brake system are attached to the traction machine that holds the elevator in place when it's not used or moving and when the power has failed. The brake system has brake calipers that creates friction with brake disc on to stop. Just like a car, when the car is moving, when you press the brake, how the car stops, it has the brake system and it has the brake calipers that presses between, like a sandwich, presses between the brake disc. So when the same as leaf, when it's moving and when it wants to stop, it creates government building. Next up is steel rope. The steel rope is a tensile steel that driven through a traction sheath attached to the motor shaft, a system of pulleys and a counterweight. Steel ropes has many variety in lift system. But in Wisma Prison 4, they are using single wrap 1-to-1 rope since it's most economical and efficiency. The steel ropes are high strength ropes that are twisted together like when they are using this. It's like a rope, like a DNA. Twisted together to create a strong, very strong strength, flexibility and durability. In Wisma Prison 4 building, Putrajaya, they often inspect the steel ropes every 6 months. Since the lift are like I said, is frequently operates and this often causing the ropes to wear down. Next up is car lift. The car lift is specifically designed by Hitachi to transport passengers or goods vertically within the building safe and comfort. Act like a car. Hence the name, the car lift. If you want to go drive, you have to be in the cabin, and the cabin must be safe, right? Same goes to lift, so to transport people. The type of car used in Wisma Prison 4 are passenger lift car. Since it's a corporate building that is frequently operated by a person and is more convenient, fast and cost effective. The last but not least is a door system. Lift door are a door that require a lift entrance which has 2 sets. A car doors that lift fitted at a car lift and a landing floor. Like there's a cabin and the cabin door like this, and then another door is at outside at the landing floor. So that is a safety feature. These are to make sure the passengers are safe and comfortable to ride the elevators. The landing doors must be in combustible material such as a steel sheet over a light steel framework of about 30mm overall thickness to reduce fire risk, like a 1-hour fire door like that. A lift door has a variety of types, but in Wisma Prison 4 they are using single speed central opening like this, because it is universal and easy to maintain and also effective, much faster. And that's all from me. To the next one.
Operation system. What is the operation system that we use in our case study? The operation system that included in our case study is traction electric motor room system. It used traction or electric lift system. Motor room located at the top floor above the lift shaft. Machine on vibration pad to reduce noise. Overhead beam for maintenance. Has light and ventilation fans. Locked door for authorized access, and it also have a trapdoor for lifting equipment. This system required all of these items to function. First of all, we need a machine room located at the top of the building, hold key from mechanical and electrical part. Second, it need electric motor, power the lift by turning the pulley, convert electricity into motion. Number third, we need traction shift pulley, groove wheel that move ropes, bells to lift or lower the elevator. Number 4, steel ropes or bell is loop over the pulley and connect elevator car and counterweight. 6, control panel system. Control lift direction, speed and stops. It takes command from button and sensor. 7, guide rails. It tracks on the shaft walls, keep elevator and counterweight moving straight safely. Braking system, stop the lift when motor is off. It also gives emergency brake work if speed is abnormal.
Conclusion. With our observation of traction lift system of Wisma Thani Putrajaya, we learned a lot of valuable information on how the elevator works, such as how the system integrates into overall building design, how the system managed to save energy as possible by using counterweight, how the type of elevator choice suit very well with the purpose of the space planning, and how regularly they maintain the elevator to be in the perfect condition. Thank you for watching and have a nice day.